Hello students, welcome to PRP lecture videos. In this video, we are going to discuss about the topic normal distribution. It is come under the continuous random variable. So this is called continuous distribution. Hello students, welcome to PRP lecture videos. In this video, we are going to discuss about the topic normal distribution. It is come under the continuous random variable. So this is a continuous distribution. In this video, we are going to see the applications of normal distribution and examples. Let us see one by one. See, first what is normal distribution? A normal distribution is a continuous probability distribution that is symmetric about its mean, with its shape described by the bell curve. Many natural phenomena, measurement errors, and statistical estimates follow this pattern. Okay, so normal distribution is one of the important concepts that is applicable to both mathematics and statistics. In future, if you are going to study the probability and statistical hypothesis, we're going to start the business, we must learn normal distribution to analyze all the data. Okay, so here what is given? Bell curve. See, in this bell curve, this is normal distribution. It is symmetric about the mean. This is the center point. This is the line is called mean, median, mode, and etc. Okay, so the shape is split this region into two equal parts. Suppose when we calculate the area under this curve, total equal to 1. When this mean divides this area into two equal parts, this is 0.5 and this is what? 0.5. Okay, see, now we are going to see the mathematical definition of normal distribution. See, a continuous random variable x with parameters mu and sigma square follows a normal distribution. Its probability density function is f of x equal to 1 by sigma into root 2 pi e power minus x minus mu whole square divided by 2 sigma square, and the limit of x is minus infinity to plus infinity, and sigma should be greater than 0 because we have the sigma in denominator. If it is equal to 0, it is not defined. So then sigma should be greater than 0. Okay. Let us see once again the parameters. What is the parameters of normal distribution? Mu. Mu is nothing but mean. Mean is the center of this distribution. See, in this distribution, center is what? Mean. And variance, the spread of the distribution, where the distribution is spread over. That is what? Sigma square. And taking square root of this one, standard deviation. That is width of the bell curve. So bell curve width only is nothing but standard deviation. Okay. Now, as per the exam point of view, and when we are going to solve the problems, we are not using this previous PDF. That is f of x equal to 1 by sigma root 2 pi e power minus x minus mu whole square divided by 2 sigma square. To make the simplification, when we substitute mu equal to 0 and sigma equal to 1. So we are going to change the x to some new variable. Let us consider the new variable is z. So z equal to x minus mu divided by sigma. This is called standard normal variable. Now z follows the normal distribution with mean 0 and standard deviation 1. Okay. Now we are going to define the PDF of this z. So if pi of z equal to 1 by root 2 pi e power minus z square divided by 2. Okay, so once again remind f of x equal to 1 by sigma into root 2 pi e power minus x minus mu whole square divided by 2 sigma square. Now this is equal to z. So z square divided by 2, sigma value equal to 1. That's why the function becomes like this. Okay. Now, what are the applications of the normal distribution? Mostly we are using height, weight, blood pressure distribution. Okay, and IQ scores. Especially it come under the statistical hypothesis, measurement errors, stock market returns, and quality control. Quality control is very, very important while we start the business. Okay, so among these examples, I'm going to take the important one, stock market returns. Almost every employers are using using and having one scheme savings in stock market. Okay, So there are several companies are there. So I am going to take Tata Motors. Okay. So let us consider Tata Motors 10 days daily return in percentage. Okay. So I am watching the Tata Motors level, and I collected the data daily returns in percentage. For example, 1.2 minus 0.5, 0.2, 2.0, 2.0 minus 1.0. So all positives are gaining, all negative are loss. Okay, so totally I have collected 10 days. Okay, now I am going to take the decision on 11th day based on this 10 data. So first what I have to do, I am finding the average. So sum of all the values divided by total number of values. See, adding 1.22 minus 0.3, I am getting 4.3. So total number of days 10. So what is the average? That is mean 0.43. So mean itself it comes the positive only. So this data may be good for keeping Tata Motors in our portfolio. Okay, suppose this is not enough. I want to find the variance. See, I am taking 10 days daily return. I subtract by the corresponding mean. Okay, so 1.2 minus 0.5 up to minus 0.3 daily return. So what we have found the mean 0.43. So I am going to check will the all the daily returns subtracted by the mean what happened 0.77 minus 0.93 and etc. Okay, so when we add this one and divided by 10 it comes what variance. Now I'm going to take the squares 0.77 square minus 0.93 square 0.37 square and we are getting these values. Okay, see, to find the standard deviation and the variance, I am taking all the squares of these values, sum of all the square deviation divided by n minus 1. So you may ask the question, why we divide not by n? Because when we divide by n, it is average. Okay, so as per this Bessel's correction, and the degrees of freedom is 1, so that we are taking n minus 1. If you are substituting n as it is, it comes error. Okay, so the sum of the square deviation is 9.520 divided by 10 minus 1, 9. What is the answer? The variance is 1.0578. After taking square root, it comes what? Standard deviation 1.0286. Okay, so first I have collected 10 days data, then I found the mean, then I am not satisfying. I found the what is the variance and standard deviation between every day. Okay, so standard deviation also it is reasonable only 1.0286. Okay, suppose if you are not satisfied, you may apply the formula to get a standard deviation. See, sigma equal to root of e of x square minus e of x square. Okay, see, e of x already we have found, that is mean of this data, and e of x square. So I square all the daily 10 days return, then add all the data. I got 11.37. Then e of x square equal to that average 11.37 divided by 10. So that is nothing but 1.137. This is only e of x square. Now we are going to apply the formula to find variance and the standard deviation. Sigma square equal to e of x square minus e of x whole square. Substitute the value 1.137 and mean 0.43. We are getting the answer. Variance 0.9521 and standard deviation 0.976. So by the table value, we called it manually only now. That is answer 1.03. So here 0.976, just the small error only has happened. Okay, so now I'm going to use the table value only, that is 1.03 and mean equal to mu equal to 0.43. Okay, see this chart, Tata Motors 10-day daily returns with the fitted normal distribution. See here, the blue histogram shows the actual return frequencies. These are actual return frequencies. The red curve is fitted normal distribution. Is fitted normal distribution. Okay, so start from -2 to 3. Width is nothing but standard deviation. Center is nothing but mean 0.43. Okay, the black dash is nothing but mean return the symmetry. So the mean divides the symmetry only now. So it that means the symmetry balances these gains and losses of the daily returns. Okay, then only you can easily understand what is the gain and what is the loss. Okay, okay. Now up to this height, probability density, it is not actual probability, it is only approximate. Okay. So what is the uses of this diagram and normal distribution? Only the purpose is the 11th day we may buy or sell. So now how this normal distribution gives the idea to buy and sell. Okay, first buy. Actually we are having data 0.43 and standard deviation 1.03 by zone. If the daily return difference between mean average of 10 days minus the standard deviation is comes -1, it is clearly shows that buying signal. Okay, so stock dropped too low, so we can easily buy the stock again. Okay, then only we can get we can keep all this one as a, we can make it what average. Okay, so this is a buy signal when it is negative. Okay, if it is sell, the sum of this mean plus standard deviation, that is 0.43 plus 1.03, 1.46 percentage. Now this is the signal for if the daily returns meet above 1.46 percentage, you have to sell this stock. Okay, this is only for intraday purpose. If you want to keep this stock for long term, you will not only see this normal distribution alone, you may check with other indicators like RSI and moving average and etc. Okay, now this is example for example point of view. See the question, an electrical firm manufactures light bulbs that have a life before burnout that is normally distributed with a mean equal to 800 hours and standard deviation of 40 hours. Find the probability that a bulb burns more than 834 hours. The probability that a bulb burns between 778 and 834 hours. Okay, what is given here? Which one is the random variable? Let us see later. Now, mean life of bulbs. Mean life of bulbs is given mu equal to 800 hours. So the electrical firm manufactures so many bulbs. Every bulb having one life. It is in the during this life. It is average is 800 hours. Okay, and standard deviation. So every bulbs are not same 800 hours only. No, someone is 834, someone 850, someone 750 like this. So different standard deviation is 40 hours. So here lifetimes of this bulb only normally distributed. What we are going to find? First, the life of bulb greater than 834 hours. What is the probability? And the life of bulb between 778 and 834 hours. Okay, so find the probability. See, what is the random variable? X. So X denote the length or life of bulb. Length of life or length of life of a light bulb in hours. See, mu equal to 800, sigma equal to 40. Now we are going to introduce the standard normal variant Z equal to X minus mu by sigma. Okay, mu 800, sigma 40. Okay, now first question is probability of bulb life greater than 834 hours. So what is X equal to 834? The corresponding standard normal variate Z equal to 834 minus 800 divided by 40. So 34 divided by 40, 0.85. Okay, so probability of X greater than 834 is required. It is equivalent to what? Probability of Z greater than 0.85. Okay, see how we are going to find probability of Z greater than 0.85. From the normal distribution property, we are able to write this one equal to 0.5 minus probability of 0 less than Z less than 0.85. How you know? See, this is Z equal to 0. Okay, so area under this bell curve is 1. So the mean divides this area into two equal parts, 0.5 and 0.5. Now we denote 0.85 here. Okay, so what is the question is greater than 0.85. So greater than 0.85. Okay, total value equal to 0.5. Okay, now we are going to find only this. So what we are going to do, the total value minus this value equal to greater than 0.85. So 0.5 minus probability of 0 less than z less than 0.85. Okay, so what is the value? 0.3023, that is obtained from the z table. Okay, right. So probability of z greater than 0.85 equal to 0.5 minus what we have found here, 0.3023. What is the answer? 0.1977. Now we are going to check how we are getting this value 0.3023. See the table, 0.8 is here, 0.8 is here. Okay, and what is the point? 0.85. Now 0.8 only is here. See the rows above, 0.05. So 0.8 in plus 0.05. So the point of intersection between 0.8 and 0.05, this is nothing but 0.3023. Have you understood? Okay, this is the way we have obtained this value. Next, probability of 778 less than x less than 834. Now we have the standard normal variate for x equal to 834. Now we are going to find what is x equal to 788 corresponding to z. Okay, right, z equal to 778 minus 800 divided by 40. Okay, what is the answer? Negative value minus 0.55. Okay, now this value equivalent to probability of minus 0.55 less than z less than 0.85. Okay, now we are going to split into two equal parts. Minus 0.55 to 0, 0 to 0.85. Okay, see, let me show you in diagram. What we are going to do, minus 0.55 and my 0.85. We are going to find the probability between minus 0.5 to 0.25. Okay, so this is nothing but minus 0.5 to 0, 0 to 8.5. Since this is symmetric answer, minus 0.5 to 0 equal to what? 0 to 0.55. See, I am going to replace this minus 0.55 to 0, like 0 to 0.55. What is the answer? 0.2088. And 0 to 0.85 already we have found 0.3023. Now, required one, probability of 778 hours to 834 hours. So 0.2088 plus 0.3023 equal to 0.5111. Okay. Now let us check the value at 0.55. So 0.55 can be written as 0.5 row, 0.05 column. Okay, so 0.5 here and column is here 0.2088. Okay, so this is very, very important. Next one. Assume the mean height of soldiers is 68.22 inches. Okay, height of soldier is 68.22 inches with variance of 10.2 inches. How many soldiers in a regiment of 1000 would you expect to be over 6 feet? That is 72 inches tall. Okay, see, this is the simplest question. What is given? Try to understand given data. The mean height of the soldiers 68.22 inches. Suppose one soldier height 75 and 80 and 78 up to etc. Okay, so average of this height is 68.22 inches. So every soldier is having some difference height only now. That is difference only, variance only 10.8 inches. And standard deviation is 3.2863. So regiment size, total number of soldiers 1000. So height threshold 6 feet equal to 72 inches. Okay. Now, what we are going to find? How many soldiers are taller than 72 inches? So how many soldiers are greater than 6 feet? That is equal to what? taller than 72 inches. Now we define the standard normal variable. X be the height of the soldier in inches. So we assume X normally distributed with the mean and variance. Standard deviation. So convert into standard normal variable. Is it equal to X minus mu by sigma? Substitute mu value and sigma value here. And what is required now? Probability of X greater than 6 feet. So that is equivalent to probability of X greater than 72 inches. Okay. So under this Z, we transform into X equal to 72. 72 minus 68.22 divided by 3.2863 equivalent to 1.15. So the given data equivalent to probability of is greater than 1.15. As usual, the bell shape. 1.15 to highest. Okay, that will be calculated by 0 to 1.15. 0.5 minus total half of the area minus 0 to 1.15. It is equal to what? Greater than 1.15. Okay. See, what is the answer now? From the Z table, answer 0.3749. So probability of X greater than 72 equal to 0.5 minus 0.3749, that is equal to 0.1251. Clear? See, the question is number of soldiers taller than 6 feet. Total regiment is what? 1000. So 1000 into 0.1251 equal to 125 point something. So it's a round number. 125 soldier is the answer. Okay.